Why do elements change properties in the periodic table? Imagine a world where every tiny particle in matter has a story to tell. The elements are like characters in a grand story, each with their own traits that change depending on where they are in the periodic table. But why do these properties shift from one element to another? Let's uncover the secrets behind this fascinating pattern. At the heart of every element is its atomic structure, which is made up of protons, neutrons, and electrons. The number of protons in the nucleus, called the atomic number, defines what element it is. When an atom is neutral, the number of electrons equals the number of protons. These electrons are arranged in layers or shells around the nucleus. How these electrons are arranged influences how the element behaves physically and chemically. When you move across a row in the periodic table, known as a period, the number of protons increases. This makes the nucleus more positively charged. The stronger positive charge pulls the electrons closer, shrinking the size of the atom. At the same time, electrons are added to the same outer shell, which increases the attraction between the nucleus and the electrons. This makes it harder to remove an electron, raising the ionization energy. It also makes the atom more eager to attract additional electrons, increasing electronegativity. These changes cause elements on the left to behave more like metals, which are good conductors and malleable, while those on the right act more like nonmetals, which are insulators and brittle. Now, when you go down a group or column in the periodic table, the story is a little different. Here, each new element adds a new electron shell, which pushes the outer electrons farther from the nucleus. Even though the number of protons increases, the added shells mean the outer electrons feel less pull from the nucleus. This results in larger atoms with lower ionization energies and decreased electronegativity. Because the outer electrons are farther away, they are easier to remove and less attracted to other atoms. This is why elements down a group tend to be more metallic and often more reactive, especially in groups like the alkali metals. These patterns, called periodic trends, help us understand why elements in the same group share similar properties. They also explain why properties change smoothly across a period. For example, sodium reacts strongly with water because it easily loses its outer electron, while neon does not react because its outer shell is full and stable. In essence, the properties of elements change because their atomic structure, the number of protons and how electrons are arranged, changes in a predictable way across the periodic table. This systematic change creates the diverse but organized world of elements we see around us.